Good morning all. Let us discuss the determination of CD for triangular notch. A notch is a device used for measuring the rate of flow of a liquid through a small channel. It may be defined as an opening in the side of a tank or small channel in such a way that the liquid surface in the tank or a channel is below the top edge of the opening. The bottom edge of the notch over which the liquid flows is known as sill or crest. You can observe in the figure. So this is the crest level. The sheet of a liquid flowing over a notch is known as nappe. A notch is used to measure a discharge of a small stream or canal. In the figure we can observe this is a V shape or triangular notch which is fixed to the one end of the open channel. The main objective or aim of the experiment is to determine the coefficient of discharge of a given triangular notch. The apparatus required are triangular notch, stopwatch, collecting tank, point gauge and scale. The experimental procedure is as follows. First, fix the notch plate under the test at the end of the approach channel in a vertical plane with a sharp edge on the upstream side. Fill the channel with water up to the crest level and adjust the point gauge to 0. Once the water becomes steady, note down the H reading, and this height of the water at the crest level will remain same throughout the varying conditions or varying the discharges. Then adjust the bypass valve to give a maximum possible discharge without flooding the notch. Conditions are allowed to steady before the rise of water level is recorded. Then note down the final point gauge reading, and this gives the head over the notch. Collect the water discharging from the notch in the collecting tank of known dimensions and measure the rise of water level R in the collecting tank for a known time T seconds. Lower the water level in the approach channel in stages by adjusting the flow control valve and record the series of readings H, R and T at each stage. For varying discharges, note down the head, then 0.1 meter rise, note down the time taken to collect water in the collecting tank. Now let us see the experimental conduction in the laboratory for the calculation of coefficient of discharge by V notch. Today we will do the calculation of CD by using a V notch. So this is the experimental setup for the calculation of coefficient of discharge by using a V notch. This is a collecting tank. This is the discharge through notches apparatus. This is a notch tank, motor, the flow regulator valve and the discharge valve which is connected to the collecting tank. The V notch has been fixed at the one end of the open channel and the point gauge have been fixed. So this is the experimental setup for the calculation of coefficient of discharge. Switch on the motor and allow the water to flow over the channel and wait for some time until the water comes up to the crest level. Once the flow becomes steady, adjust the point gauge such that the point gauge tip has to touch the top surface of the water. Note down the height of the water as H. It remains constant for all the conditions. Switch on the motor and close the flow regulator valve completely so that the maximum discharge is allowed to flow in the channel. So once the flow becomes steady, again adjust the point gauge. The tip has to touch the top surface of the water. After adjusting the point gauge, note down the reading H1 for maximum discharge. Close the collecting tank discharge valve completely and note down the time taken to collect in the collecting tank. Time taken for the water to collect in a collecting tank by noting down the reading in a piezometer for 0.1 meter rise by using a stopwatch. Note down the time taken. Again open the collecting tank discharge valve and adjust the flow regulator valve for medium discharge. The discharge is reduced in a channel. We are calculating H for medium discharge. Again, after some time, you have to adjust the point gauge in such a way that the tip of the point gauge has to touch the top surface of the water. After adjusting the gauge, again note down the height of the water as H2. Again completely close the collecting tank discharge valve and note down the piezometer reading, that is a rise 0.1 meter rise. What is the time taken for the water to collect in a collecting tank? For third condition or the third trial, open complete flow regulator valve so that the discharge level will be reduced in a channel. Again, after some time, when the water or the flow becomes steady, adjust the point gauge and note down the reading as a H3. So note down the reading H3, and again we have to note down the time taken to collect water in a water tank for a 0.1 meter rise by closing a complete discharge valve. So after the 3 trials, the observations and calculations have to be done, and you have to calculate the theoretical discharge as well as the actual discharge. With that, we can calculate the coefficient of discharge. After doing the experimental work in the laboratory, the last part is the observation and calculation. Firstly, the breadth of the collecting tank we have noted down, that is B is equals to 0.3 meter. The length of the collecting tank L equals 0.3 meter. Area of the collecting tank can be calculated, that is A equals L into B, that is 0.3 into 0.3, we will get 0.09 meters square. The theoretical discharge through a triangular notch, that is Q theoretical, can be calculated by using a formula 8 divided by 15 into root of 2g into h to the power of 5 by 2 tan theta by 2. So here h is the height of water surface above the apex of the notch. H equals h1 minus h2, where h1 is the height of the crust of the notch, h2 is the head of water above the crust point of the notch, and theta is the angle of the notch. So here the angle will be 60 degree, and g is the acceleration due to gravity, 9.81 meter per second square. Then we can calculate the actual discharge, that is Q actual equals AR by small t. So discharge will be in meter cube per second, where A is the area of the collecting tank in meter square. Already we have calculated and we have obtained the area as 0.09 meter square, and R 0.1 meter rise of water level in the collecting tank, and T for corresponding 0.1 meter rise time taken to fill in the collecting tank we have noted down. Then with that we can calculate the coefficient of discharge CD by using a formula Q actual by Q theoretical. So this is the tabular calculations. So after noting down the values of H1, that is H1 remains constant for all the 3 varying conditions, and H2 is noted down for varying the discharges, that is for first trial we have obtained the value for maximum discharge, H2 we have got 0.079, and for medium discharge we have obtained the head as a 0.08, and for low discharge we have obtained the value as 0.09. So with that we can calculate the head over the notch for varying discharges or for various conditions. And for each trial, the corresponding time taken for 0.1 meter rise of water to collect in a collecting tank have to be noted down. For the first trial we have got 12 seconds. So by using the previous formulas what I have shown, that is the Q actual and Q theoretical, you can calculate the values and you can obtain the CD value, that is CD equals Q actual by Q theoretical, that is 0.623. Similar way we have to calculate for other two trials, and we have to obtain the values of CD, that is 0.661 and 0.565. So after that we have to calculate the average coefficient of discharge. So in the present experimental work we have obtained the average CD value as 0.62. So this is the observation and calculation part for the determination of CD by using a triangular notch. Thank you.